All right, next up, I want to introduce Clay Dagler, the mathematics and computer science teacher in Sacramento. He uses programming and robotics to give his students a deeper understanding of mathematics. For the past 10 years, he's improved education in California by leading several talks at statewide conferences and published an article in California Mathematical Council magazine. And his students are represented in at a table out in the Innovation Center. So once he tells you his story, I strongly encourage you to go out and check out what he's actually been able to produce, because it's pretty darn impressive. Please join me in welcoming to the stage Clayton Dagler.
The way we teach math today is challenging for several students, teachers, and parents are having a hard time adjusting. It'd be very difficult to find a person in California that has not read a Facebook post complaining about the frustration of the new Common Core mathematics. Excuse me, sorry. So by the time this presentation is over, I plan to show you how we can use robotics and computer programming to actually make math fun again and where you want to be. I've been teaching at Luther Burbank High School since 1999. In this time, I've taught mostly mathematics and some computer science. For the past 4 years, I have blended these two subjects together and added robotics by partnering with the C-STEM Center. So now I'm using robotics and computer programming to make math more interesting to the students that I'm speaking to. When I think about teaching mathematics, I put problems into two categories: procedural and conceptual. Procedural knowledge includes knowing the definition of the radius of a circle, the steps to add fractions, and using the quadratic formula. Conceptual knowledge includes word problems, understanding the graphs of cubics, and comparing a linear expression to its table. To help my students improve in procedural knowledge, I have created several practice programs which generate controlled random problems for each student to solve. These programs also provide feedback on the students' solutions. I realized that procedural knowledge learned in a high school math classroom may not be needed for the workforce. For example, you probably wouldn't hire someone if they put "I can factor 35 quadratic expressions" on their resume. Or during an interview, they say they know the surface area of a cone. That's just not what you guys are looking for. I'm happy to say that these skills are covered. The skills that you guys are looking for are called transferable skills, and they're covered in the SMPs, which stand for the Standards of Mathematical Practice. A big part of programming is making sense of a problem and persevering in solving it. Creating a valid argument on how to solve a problem is an important skill in the workforce today. And just as important is to know how to look at someone else's solution critically. Math applications are important to get my students ready for high-quality jobs after high school. Most teachers will use calculators, protractors, and rulers as appropriate tools. I am adding programming and robotics to the list. Here is the first math activity I do with the robots. Each pair of student gets a Linkbot configured as a two-wheel drive car. It's shown in the upper right. They write a program that moves the robot forward by turning each wheel 15 degrees and measure how far it went. After that, they repeat this process for 30 degrees, 45 degrees, 60 degrees, and 120 degrees. And then they plot the results. They can use this graph to get a pretty good estimate of the function of the distance the wheels turn versus how far the robot traveled. After this, we go to the algebra. The students take the radius of the wheel to calculate the circumference of the wheel, and they use proportions to get the exact equation of the line. Getting students to understand word problems is a big job of mine. The main reason why students have a hard time understanding word problems is that the variables they use are far too vague. In this example here, a typical student would write, let X equal drink. Is that the number of drinks, the cost of one drink, or the total cost of all the drinks? This code sample here gives the students a much deeper understanding of the mathematics, because they have to identify exactly what each variable is and what type it is. Is it an integer, or is it a double, or decimal? One topic students are introduced to in high school is solving inequalities involving absolute value. This is a very difficult topic for the students at first, because this is the first time a problem has two sets of solutions. A vast majority of textbooks teach us with a magic trick that leaves the students no chance of understanding what's going on. So what I do instead is I have the students write a computer program which generates this graph. And then afterwards, I simply ask the students, where is the red graph above the green line? In this case, it's pretty easy to see. It's where x is less than -7, as well as when x is greater than 1. I use robotics simulation to introduce my students to solving two-dimensional linear systems. Most teachers use a procedural approach by simply just doing one problem and have the students practice 15 just like it. Me, on the other hand, I have the students write a computer program that has the robots travel in their own linear path, and the students are faced with finding where do they cross. Because where they cross is the exact same thing as a solution to a system in a typical algebra book. I created an animation that calculates the area of several polygons about a circle of radius 1. This shows how the area approaches pi as the number of sides increases. Before this animation was shown to the class, each student was faced with finding the area of one of these polygons. And they posted the results to a large organized table, which started the discussion for the whole class to see. To give my students an understanding of functions, I have robots line up on the x-axis ranging from x equals -3 to 3. Then each robot drives to its correct y value to show the graph of the given function. This hands-on and visual representation gives the students a much deeper understanding of functions that you can do with pencil and paper. This video is showing an exponential function, but I did this with all the functions covered in my class. Okay, you got me. This is not going to show up in a typical math textbook. But modular robotics, which is robots connected together to form a new single unit, expands across the Common Core mathematics. Some standards covered include angles, symmetry, making sense of a problem and persevering in solving it, attending to precision, looking for and making use of structure, and as well as repeated reasoning. I believe these are the standards that the workforce is looking for today. I would like to thank everybody for listening to my talk. All the material can be downloaded on my website, mrdagler.com, by clicking on the Emerging Technologies 2016 link. Thank you guys for your time. Cool, thank you very much, I appreciate it.
Now, be honest, wouldn't he have been cool as a math teacher?